Here's your chance to try your skill at energy hopping. The diagram shows the energy level diagram and the line spectrum for a hydrogen atom. In addition to the visible lines that we can see in the spectrometer, there are also groups of lines in the ultraviolet and infrared regions of the spectrum. The diagram was obtained by analyzing the line spectrum from a hydrogen lamp. Notice how the energy levels get closer and closer at high energy. Now you must try to fit the energy change to the lines in the spectrum below. The rules of the game are as follows. Click on Excite Electron to excite the electron. The electron will jump to one of the excited state levels chosen by the computer. The level which it drops to will also be chosen by the computer. An arrow showing the size of the energy drop will appear. You must now click to select the line in the spectrum that you think corresponds to this drop. If you are correct, the arrow will move across until it is over the correct line and you will score 10 points. If you are incorrect, the arrow will still move across until it is over the correct line, but you will not score any points. Excite the electron again and repeat. If the electron has not reached the ground state, then another drop will be indicated. You will have to select the line in the spectrum for this second drop. Complete all the drops until the electron reaches the ground state, or start again by clicking on Excite Electron. Continue until you have identified all the lines in the spectrum. Summary. The complete line emission spectrum for hydrogen shows several series of converging lines, in addition to the one in the visible region. The one at highest energy is in the ultraviolet region, 2 more are in the infrared microwave regions. The patterns in the series of lines correspond to an energy level diagram which shows the energy levels getting closer and closer together at high energy. You should, as a result of playing the game, be able to see how different series of line arise in the hydrogen atom spectrum. What do all the electron drops in the same series have in common? Answer: they start from different levels but all end on the same level for one series. You may have noticed that in each series the lines get closer and closer together in one direction. Which direction is it? Answer: towards higher energy or frequency. As the frequency increases, each line becomes closer to the previous line. This is because the higher the energy levels, the closer together they become. The difference in the quantum of energy given off gets smaller and smaller. Click anywhere on the energy diagram to put in the remaining energy levels at the top of the energy diagram. As you can see, they eventually become so close you cannot tell them apart. The lines converge at the high frequency end. The convergence limit is the frequency at which the lines converge and cannot be differentiated. The series of lines resulting from drops from higher energy levels to the lowest level, to n equals 1, is called the Lyman series. The Lyman series appears in the ultraviolet region of the spectrum. The higher the energy level of an electron in the hydrogen atom, the further away from the nucleus it becomes. Once the electron reaches the highest level, it will leave the atom if it gains any more energy. When the electron leaves the atom, an H+ ion is formed. Hydrogen gas is converted to hydrogen ion plus electron. The minimum energy required for this process is called the ionization energy for hydrogen. This energy corresponds to the difference in energy between the lowest and highest energy levels in the hydrogen atom. Click on the energy diagram to see the drops in the emission spectrum that has this energy. Which line in the spectrum corresponds to this drops? Answer: the highest frequency line in the Lyman series. Finding the frequency of this line, and hence its energy, enables us to work out an accurate value for the ionization energy of the hydrogen atom. Summary: each series of lines in the hydrogen atom spectrum arises from drops of the excited electron to the same common level from many different higher levels. The Lyman series, at highest energy, arises from drops to the lowest level from all the different higher levels. The lines in any series converge to higher energies until they reach a limit which is called the convergence limit. In the case of the Lyman series, this limit corresponds to the largest drop on the energy level diagram, from the highest to the lowest level. The higher the energy of an electron, the further away from the nucleus it is. Once the electron has reached the highest energy level, if it gains any more energy, it will leave the atom. The energy involved in the biggest drop is equal to the energy that would raise an electron from the lowest energy state to the highest. For the hydrogen atom, the ionization energy can be calculated from the frequency of the line at the convergence limit of the Lyman series.